then. And if you missed some of this, this was in the notes from before. So now let's think about the effect of temperature. So K2 is an elementary rate constant. And so its temperature, if you increase the temperature, its rate will increase. So here again is our equation. The activation energy is always positive. There's always some barrier to overcome. So if you increase the temperature, you're always going to increase the elementary rate. Well, what about equilibrium constant? So we've talked about this back in chemical equilibrium, that the effect of temperature on an equilibrium constant depends on whether the reaction is endothermic or exothermic. And you told me before the equation, and that's the Van Hoff equation shown here. And so look how similar those equations are. So for an elementary rate constant, we have EA, and for equilibrium constant, we're talking about delta H. So if you have, here the reaction is exothermic, and if you increase the temperature of an exothermic reaction, what happens to K? It decreases. So again, it would shift then to the endothermic direction, decreasing K. So let's look at this then. So we have in this K-obs term, we have an elementary rate constant and an equilibrium constant. So if you increase the temperature, the rate constant increases, but the equilibrium constant is going to decrease. So the magnitude of the increase or decrease depends on the size of the activation energy or the size of delta H. So for this particular example, there's no way that you would know this, so I'm telling you that the activation energy is a small number, or you might be able to look it up in your book, and delta H is a very big number, and it's negative. It's an exothermic reaction. So if you have a very small number for EA, that means that the rate constant will increase only a little bit. It's not that sensitive to a change in temperature because EA is a very small number. But if delta H is a big number, then the equilibrium constant would decrease a lot with temperature because this is a big number here. So in this particular example, increasing the temperature actually decreases the observed rate because delta H is, in this particular example, a much bigger thing. So if you were given either numbers or some information like that, you should be able to rationalize what might be true about the rate of the reaction.